Lesson 7, volumes, for the third and final time. Okay, now, we are still talking disk method. We are still talking washer method. But we are revolving around other axes. So, instead of our axis of revolution being the x-axis or the y-axis, it will be other vertical and horizontal lines. We will keep it vertical and horizontal. Okay, we won't get anything crazy here. But we do have to consider how things are affected when we're rotating and get around some other axis. Okay? So, we're exploring volumes revolved about any line other than the x or y axis. You should feel comfortable in basic understandings that if we rotate about any horizontal axis, then the cross section will be a function of x. So, when we rotate around the x-axis, we do everything in terms of x, right? So if we do any other horizontal line, you're still going to be working in terms of x. Whereas when we rotate around the y-axis, we work in terms of y's. So any other vertical axis is going to act just like another y-axis, and you will work in terms of y's. Now, we're going to focus first on horizontal axis of revolution, and I think I'm going to make this a little bit bigger so I have a little bit more room to write here. Okay, so focusing on horizontal line of axis of revolution. So to rotate about a horizontal line, which we're going to call y equals c, which if you haven't gotten it straight in your head lately, it should be there pretty well now, but y equals a number is a horizontal line, yes? Okay, when it crosses through the y-axis. So to rotate about a horizontal line, y equals c, we're going to have outer and inner functions still. So I still think of them as big R and little r as functions of x, and you're integrating along the x-axis. Now, we're going to write out some general forms of volumes for the area R, where any cross-section is perpendicular to the axis of revolution. Excuse me. So, looking at example 1. And right now we're just talking about general setup. We'll get into more specific examples later. But general form here. What are we revolving around first of all? You've got to understand that we're going to be revolving around that horizontal line, y equals c. And what we're trying to revolve around that horizontal line, y equals c, is this shaded area, yes? And so as you think about revolving this shaded area around, first of all, realize this is going to be a disk or washer. We're rotating this around that upper axis, then there's definitely going to be a hole in the middle here, right? Okay. So we are talking a washer method. And we talk washer method, we talk big R squared minus little r squared, yes? So when we talk big R squared minus little r squared, we talk about it's basically the outer radius minus the inner radius. Okay. Well, as we look about this, here's my vertical cross section. And I'm going to call that big R. If I go back to using my big R and little r's, right? And that's big R because that's the distance from my axis of revolution to the outside of the object. Now, what is that distance?
C.
Why C? Because, right, it's going from the x-axis, which is 0, up to this y equals c, which has a value of c. So when we talk about R here, it's going to be c, big R that is. Now, what about little r? Where do I want to put little r? Little r is going to be the distance from my axis of revolution to the inside, right? The inside radius. Thoughts on that distance in terms of this problem? What is this little r, the distance between? This horizontal line, which is c, and this function, which, was it ever labeled here? Because in my notes, I'm pretty sure I called it f of x. They never called it anything, did they? Okay, so just generally speaking, we're going to call the function f of x here. It's just not labeled. Oh, it's labeled down here in these two. Okay, here you go. We're going to call that function f of x. It just didn't get labeled on there. So, what's the distance between that horizontal line y equals c and my function y equals f of x? When you find the distance between two things, you subtract them. And we generally say bigger minus smaller. In this case, we don't have, it's not like you're just subtracting two numbers, but bigger minus smaller is going to be the one with the higher value minus the one with the lower value. So for little r, I'm going to say it's c minus f of x. And we're ready to write our volume formula, which is what we're just practicing doing here. Now, you guys know the basics. Volume using our washer and disk method. What do I start with? Pi times the integral from a to b. Old news, right? And then how do we set this up? Okay, so it's big R squared minus little r squared, right? That part hasn't changed. Big R is just c. And so, and I guess if you want, maybe I should have said this differently. I said it's c because that's that distance there, right? You could, if you wanted to, think of that as c minus 0, because what is the x-axis? It has a value of 0, right? But so I'm just going to say it's c minus 0, or in other words, c. So it's going to be big R squared, which is c squared, minus little r squared. Now keep in mind that is c minus f of x quantity squared. You're not squaring each individual piece, you're squaring the quantity. And then we're going to enter our integral and say times dx. I think the parentheses is half the battle here on some of these, honestly. Okay, so we're still doing the same thing. It's still big R squared minus little r squared. It's a matter of finding the big R's and little r's, which I always try and do that before I go into a problem, because otherwise I really can get confused. Okay, now, what changes this time?
C's on the bottom.
Yeah, this time my axis of revolution is down below my curve and my x-axis. Okay, so this time C has a negative value. What's big R? Big R is going to be the outside, right? So big R goes from the distance of the curve farthest away from the axis of revolution. What would you say about big R?
F of x minus C.
Okay, so it's f of x, which I just labeled in there, sorry. Now, yes, I agree, minus c.
Because it's minus a negative, so.
Right, and so we can think of this a couple of different, I mean, it's in my notes, I have minus negative c, because what do we know about c? C is going to be a negative value. So what are we going to end up doing since c is going to be a negative value? We're going to end up adding it, right? And so it's going to end up being f of x plus c. And I think I want to say here, okay, I'm going to make a note here. Y equals c is below x-axis. Whoops. So c value is negative. So just a little side note there. We also need little r. Thoughts on what little r is going to be? Okay, at least one person realizes what I did here. What's wrong with my little r?
You drew to the
It's
f
not
of
the
x.
little r.
It's not the little r, it's big R, isn't it? Sorry, Maddie. Yes, your teacher makes mistakes. Okay. Where's little r supposed to be?
There.
The inside radius. Gosh darn it, guys.
I thought nothing of it.
I wonder if I would have kept going, if anyone would have mentioned it or pointed out to me. Okay, what about little r? Okay.
Do you put like absolute value on it or no? Like does it?
Well, and here's what I'm going to think. If we're doing the upper curve minus lower curve, right? So this one was f of x. Officially, it's going to be minus negative c, because c is going to be a negative, and so it ends up being plus c. This one, what is this curve right here? This is the axis, right? And so it's going to be 0 minus negative c. Now, if it's 0 minus negative c, what ends up happening? It ends up being c. Okay? So it's kind of up to you how, I guess the key here is to realize that that distance is a distance of c, right? And that's what matters. And because whether you put it as plus c or negative c right here, you're getting ready to square it. And so when you square it, it's going to become positive no matter what. Okay, did you write a formula? V equals. Okay, I got part 1. V equals pi times the integral from a to b. Okay, the quantity of f of x, she said plus c squared, or plus c, quantity squared. I just wrote minus negative c. I tend to do that just as we're beginning. Feel free to write plus c. Okay, then what? Minus, and then it's going to be c squared. And then working in x's, so dx. Okay. So those first 2 examples, we had axis of revolution above, below, and one of the borders was the x-axis then, correct? Now what?
Now we have 2.
Yeah, now we have 2 curves. You will notice here, it was c minus f of x. Here we just reversed it, f of x minus the c value, right? Okay. Now, this time it's labeled as f of x, g of x. We are rotating around the y equals c line. What's big R go between? Mm-hmm. Trying to decide where I have room here. Okay. Big R is the distance between g of x and c. If we're going for bigger value minus smaller value, this is going to be of the order c minus g of x. If c has a higher value, it's higher on the graph. And so c minus g of x.
I'm confused how we're figuring out which one minus is. Like, I don't know how.
So when I say higher value minus smaller value, the one with the higher value is going to be the one that is farther from the x-axis. And so in this case, my horizontal line c that function has a higher value than g of x because it's higher from the or farther away from the x-axis at that point.
So it's kind of like upper minus lower.
Yeah, upper minus lower in a way. Over here on big R, we had the function, and then the c was the lower. So it was upper minus lower here. So that's why it was f of x minus c. Over here, c is higher, so we're doing c minus g of x. Trust me, it takes a bit to get it figured out. This is something that always, it takes a moment. What about little r then? Oh, I never labeled big R. C minus f of x. Because that c has the higher value minus the f of x. Now, can you write your formula? Volume equals pi times the integral from a to b of c minus g of x, quantity squared, minus c minus f of x, quantity squared. Don't forget, dx. Okay. You can probably almost predict what's going to happen on this next one. Yes? Maybe? Maybe not? I say, can you guys see the orange if I do just the orange on the white? I debated. I thought about it because it was a nice contrast here. Okay, we're rotating it around. Y equals C, yes. That's half the battle, knowing what you're rotating around. We need a big R. We need a little r. What's big R? F of x minus c. Well, what do we know about c here? It's going to have a negative value, isn't it? Okay, so it's going to end up being f of x plus a number, but it really is minus that number. What about little r? G of x minus negative c. Okay? And volume equals pi times the integral from a to b of f of x plus c quantity squared, or f of x minus negative c quantity squared, minus g of x minus negative c quantity squared dx. Okay, guys, you got the basics. When this just basic c, f of x, and g of x. Now we've got to put it actually into play here. Okay. Then we got to talk about vertical axes. Right now it's just horizontal. Okay. Let's see. We have to draw a picture for this next one, don't we? Because you guys are pros at this now. Y equals square root of x. Y equals 0. X equals 4. All about the line, y equals 4. Okay, so About the line y equals 4 means that is what we're revolving around. Okay? Now, y equals 0. Yeah, y equals 0, that's just a fancy way for saying x-axis, right? So we need y equals square root of x, which what is square root of x? Sideways parabola, just the top half, because it's just positive square root of x. So that, the x-axis, and x equals 4, which is just really giving us our boundary. Where are we stopping? Now, big thing we need to figure out is as we draw this curve, we're drawing it over to 4, if you will. My question is my square root graph going to cross up through here? Not by 4, right? Because what do you know at 4? What's the ordered pair at 4? 4, 2, right? So if we're going just to right there, that ordered pair 4, 2. This ordered pair, of course, is 0, 0. And the piece we are rotating is that piece right there, correct? In all honesty, I didn't need to extend my square root graph. I just started drawing and I tend to forget to stop. Okay. So, they're going to walk us through in baby steps. Well, that's what they're going to walk us through in steps. Better. Outer radius, inner radius. That means I need big R and little r, yes? What are your thoughts about big R? Yeah. Big R is going to the outside radius there. And when we go to that outside radius, we're revolving around 4. This line is 0. So if you want, you can think 4 minus 0. But it is just 4. You don't even have to think 4 minus 0. But if you want to get in that groove of my big R and little r, always something minus something, that 0 is the piece to fill in. What about inner radius? Yes, because it'd be 4 minus our function, right? If we're doing what we did on the other page. Our function this time is square root of x. So 4 minus square root of x. Method, what they're asking for, is this a disc or washer? And there's going to be a hole, isn't there? So since there's going to be a hole, this is a washer. Okay. And now we have to do the problem, of course. We don't get to stop here.
Man, that'd be so nice.
Well, we got to practice some. Okay. I'm stopping short on my help this time. Pi times the integral.
0, 4.
You guys okay with 0 to 4? Because we need we're working in x's, so we need our x values. Now what?
Either way, you could have gotten to the right piece. The y was 4, 2.
But this y isn't 4.
Oh. Never mind.
There's lots of ways you could go wrong here and still go right, though. I understand. Okay, what am I doing? Outer radius is 4, so 4 squared minus 4 minus square root of x, quantity squared, dx. Let the fun begin. What do we have to do?
16.
Maddie took the easy one. She says 16.
Minus 16.
Now I'm going to put this in parentheses. So minus the quantity. 16, then what?
8 square root of x.
Okay, 8 square root of x plus x in the quantity and times dx. I don't think I ever said out loud, but we foiled there, didn't we?
Yes, sir.
We're pros at foiling in our head finally?
No.
Close enough.
Okay, maybe not pros. I don't know, I have seen some erasers going, so. Now, I have not distributed the subtraction yet. Maybe you already did that. To each their own, right? So I'm going to write this one more time as an integral. Pi times the integral from 0 to 4 of eight square root of x plus x.
Sir.
Although, I don't know, do you want to say 8 square root of x, or
8 to the 1 half.
could you say 8x to the 1/2 if your brain works better that way? Your choice, right? If you are thinking, man, I wish I would have, because what we're getting ready to do next is to integrate. So if you'd rather go ahead and call that a 1/2, I don't know why. My brain sometimes does better if I can see the 1/2. Sounds silly, I know, but. Okay, integrate away. Add 1 to the power. Divide by 3/2, which is multiplying by 2/3. 2/3 times 8 is indeed 16/3. So 16/3 x to the 3/2. Integral of x, 1/2 x squared, evaluated from 0 to 4. I will say, I feel like these notes and the homework, they are way too nice to use so often, because that second number is 0 way too often. You're getting spoiled.
Yeah.
So, just saying.
I like it.
Although I feel like there's been a lot of 1s, and this one's actually a 4, so you actually have to think here. So 4 to the 3/2. Do you know how to do this without a calculator?
8.
The denominator of 2 says the square root of 4 is 2. 2 to the 3rd is 8.
8 times 16.
Whatever 16/3 times 8 is.
Wait, sorry, is it minus x? Should it be minus?
Well, shucks.
Really, Ethan?
Why did you have to wait till like 3 steps later?
Sorry, I did it in my notes, and I'm looking at it, and then I see the plus, and I'm like, that doesn't match up with what I have. Are you kind of like?
Okay, I have to agree, unfortunately, 3 steps later, that it's a minus. And that's because, I'm right here, guys, I'm with you. The minus distributed to the plus, it should have been a minus. Man, 1/2 x squared evaluated at 4. 4 squared is 16, half of 16 is 8. So if I do this without a calculator, then I'm multiplying 16 times 8 in my head, which is 6 times 8 is 48, carry my 4, 8 times 1, so that's 128 over 3, minus 8 with a denominator of 3 is going to be 24/3. 128 minus 24 is going to be 104 pi over 3. And I did it without a calculator. Okay, Megan does not like that. Wait, okay, I do agree with my answer key before I go any farther here.
I got a 32. Like, 32 is
between step
8
2 and
times
step
4.
3.
Hold up.
Something ain't right here.
Are you looking at, did you add these two 16s?
Yeah.
But if we were subtract big R squared minus little r squared, so
And
the 16s are going to cancel.
Gosh darn it.
Sorry, I'm like, you got a 32. I have no idea where you're at, what you're talking about. Okay,
Okay.
Okay, I'm good.
okay.
How much of this is without a calculator?
I'm looking at this as good practice here. And, you know, as what I was saying before class, I'll be honest. When I'm doing some of these in my notes. I'm doing most of it by hand, but like something like 16 times 8, it's very possible I'm grabbing the calculator, multiplying just like you guys. It depends on what it is, but on the flip side, did I just do that 16 times 8 without a calculator? I did. It is doable.
There it is. Sorry.
So, okay, ready to try the other one?
I'm ready.
But I don't
Let's go.
know.
Y equals 4 minus x squared. Y equals 0, about the line. Y equals negative 1. So, right here is the line y equals negative 1 that we are revolving around. Okay. Y equals 4 minus x squared is what?
Parabola.
Upside down parabola.
Upside down parabola,
Up 4.
vertex at 4.
Yes, sir.
Okay, now, before I draw this too far, what is y equals 0? The x-axis. So what's happening here? I can draw it all I want, but the area I'm revolving is going to stop at the x-axis, yes?
Wait,
Are we understand? Does that make sense?
could it not be like between the two lines then?
You could draw the parabola there.
Right, but could you read it as instead of up here, you're doing it in there?
No, because it's between the curve 4 minus x squared and the x-axis. It's not the color I thought it was. So when you're looking at between those two pieces, it's going to be here because it's underneath that curve to where that you cross that line. Because otherwise my area is never going to end. We're going the area below that line. Okay. What are you guys working on? Anything? Nothing?
We should find out where it crosses where it touches the x-axis.
Okay. Should we know those points, you think?
Probably.
Do I know them? No. Should I probably know them now? Figure it out.
Okay.
2 and negative 2. Yes.
So it's up.
Ethan,
Yeah.
just set the equation equal to 0.
Yes, sir. I got it. I figured it
He's
out.
doing the mock.
Hey.
Okay, options. Maddie says set the equation equal to 0 to find your zeros. So then 4 equals x squared. X is going to be plus or minus 2. So this is the ordered pair 2, 0. This is the ordered pair negative 2, 0. Okay. I also looked at it as it's a parabola that's up 4. My first set of points go over 1, down 1. My next set of points go over 2, down 4. I tend to use that idea of the parabola. So, okay. You got an outer radius yet? That is the cleaned up version. I had to double check. Okay. I agree with 5 minus x squared is the final version. Can we all get to there?
4 minus x squared.
Okay. So the upper piece is 4 minus x squared, correct? That's our function. And then officially I'm going to say minus, and what's my c value? Negative 1. So this is because the c value is negative and ends up being a plus 1, yes? So now, do you want to do this, or do you want to go ahead and clean it up and say that it is 5 minus x squared? I will tell you guys in notes or in homework, beware, the cleaned up version sometimes magically appears. Sometimes you have to do a little bit of work to figure out the cleaned up version. Okay, I can handle that for big R. What about little r? I agree with 1. If you want to be official, It's the x-axis, which is 0, minus your c value, which is -1. Regardless, it is 1. I agree.
Washer method.
Maddie claims a washer method.
I second the motion.
Why not NHS?
All in favor?
I was going to say, are we going to get this motion approved then at this point? I feel like I'm at a board meeting.
Those are fun.
I feel like I'm in NHS.
Okay,
I mean, technically.
let's do some math. There you go. You get v equals from me.
Can you do 2
Huh?
Can you do 2 pi?
I mean, you could.
Can we do 2 pi?
I'm gonna do 2 pi.
That's fine.
I mean, 2 pi is better than 1 pi.
Okay. Now,
Well,
we can't do 2 pi
do I get
because
my
this is
calculator?
symmetric. Because, okay, so I'm going to write it with pi for just a moment. If we do pi, set your boundaries and then we can discuss it. Because if we do just regular pi, what are my boundaries? -2 to 2, yes? And when you look at that -2 to 2, is that symmetric -2 to 2? It is. So could you jump and instead say, never mind, I want to do 2 pi times the integral from 0 to 2? You can. I'm going to fill in the other one now, rather than writing it out twice. Now, and you're spoiling yourself then, right? Because we're going to use a 0 instead of a -2 to plug in. So, and I will say, most of the time in the homework, guess what? She uses symmetrics. There was one time I was shocked she didn't. I can't remember if it was in the notes or homework, but. Okay, guys.
185 minus x squared squared.
Okay. 5 minus x squared, quantity squared. Minus
1 squared.
1 squared. Times dx, change in x. Okay, so we are foiling first, yes? 25
Minus 10x squared. That's so nasty.
minus 10x squared
Plus x to the third.
plus x to the fourth
Minus 1.
No.
minus 1
But even.
dx.
The 10x squared.
I'm going to clean up one more time before I integrate.
Still.
And we know that 25 minus 1 is going to be 24 minus 10x squared plus x to the fourth. This integration isn't bad. We get worse stuff. Integral of 24 is 24x minus integral of 10x squared, 10 thirds x cubed, plus the integral of x to the fourth, one-fifth x to the fifth. And we're evaluating from 2 to 0. So 2 pi, 24 times 2, minus 2 to the third is 8, times 10, 80 over 3, plus 2 to the fifth is 32, over 5. And then what happens when you put it in 0? Nothing. Now, I feel like I saw this common denominator a lot.
This is homework last night.
I can't remember if it was this lesson, the last lesson. I feel like we've done this one a lot. Common denominator of 15. And this is where I grab the calculator, and I don't put it all in the calculator. I still do the pieces by hand. But, like, I don't know what 48 times 15 is.
2,400.
720.
I got 720.
20.
Oh, man.
Well, that's what I get for trying to do it by.
Wait, so
Oh, I got this one.
720 over 15, 80 times 5, I got this one, 400 over
Yes, sir.
15, plus 32 times 3, it's 96 over 15. See, I would have done the 48 times 15 in my calculator, and then I'd probably do this in my calculator. I don't need to, but 320 plus 96,
720 minus.
so 416 times 2, 832? Yeah. Because officially it would be 2 pi times 416 over 15, but that is 832 pi over 15. And I know as annoying as it is, you can do that by hand. Yes. I mean, no, he tried to do it by head, by brain, and there was a malfunction there. If he would have written it down, I would like to think he would have had better success.
Don't
So-
say
You're
what you're
not a malfunction in your brain.
Katie, the head raise? Yeah.
Okay.
If you feel offended, I'm sorry.
It's okay, Sorley. I would have
Now, those are a couple of examples of horizontal axis. Now we're going to do a couple of examples, or now we've got to set up vertical, and then we have some examples to go with that. Okay? Now, where am I at on time?
No time.
Yeah, mine's
I got 5 minutes. How is that no time?
Never mind, it's back to 3. Oh, yeah.
Now, I will say, with the horizontal axis, we tend to do a lot of upper minus lower. What's that mean we're going to do in vertical?
Right, minus 1.
Right minus left, okay?
Negative.
Because if I'm going to get confused, it's going to be on these. I'll tell you right now. Bigger minus smaller, right minus left.
left minus right.
Don't listen.
No.
Okay, so
That was the problem.
vertical axis. To rotate about a vertical line, x equals c, we're still using outer and inner, but it's going to be functions of y, and we're going to integrate along the y-axis. So we're going to write general forms of the volume for the area are where any cross-section is perpendicular to the axis of revolution. Well,
Spinny.
there you go. We're rotating about that x equals c. I don't know. I was taught to draw that little rotation thing years ago, and I like it because
I just picture a spinny.
It's just fun
What?
to draw.
I like it because, especially now, I've got 2 vertical axes. Like, which one am I rotating about? You know.
I just picture.
Okay, so we need a big R and little r, right? Sorry, I'm stuck. Big R, little r, is that what I should be asking for? Yeah.
Could it be C?
Okay, so big R, so I'm rotating around this axis, yes? So big R is going to go from here to the outside edge of my shape. So what are your thoughts about big R? C?
C.
Officially, we could say C minus 0 if you wanted. But C is just, I mean, you can see that distance is C. Little r goes from my axis of revolution to the inside radius. Thoughts on little r?
C minus F of X?
Okay, and again, it's not labeled, is it? But we're just assuming, whoa, not f of x,
F of
F of Y. Oh no.
because this is going to be x equals f of y. So officially, it's going to be C minus f of y.
That's weird.
So here we go. V equals
A to B.
pi times the integral from a to b of
C squared.
big R squared, so c squared, minus
F of C. C minus F of Y.
c minus f of y quantity squared
dy.
dy.
Dy dx.
Okay?
And this is why you have
And I'll stop here.
brain cells. Brain cells.
See,
So, tomorrow we can start here and go from there. Okay?
Jakey, I think we have more than one brain cell between the two.